Time now. The last presentation will be made by Dr. Lilia Rodríguez Tapia. She has a BA in economics by the UAM Azcapotzalco, an expert in international trade from the Polytechnical National Institute. She has a master's in economics by the CIDE, and in 2009 she obtained her PhD in economic sciences from UAM. She has been a member of the Mexican Committee for the Attention of the International Organization of the Standardization of ISO, and for 2006 member of the Committee of the Management of Water here in UAM. She has participation in many topics, the quotas per discharge of residual waters. That was an interdisciplinary research that was created for the restoration and the evaluation of the environment in cooperation with the regional sector TZ from Germany. She has authored many books and articles and essays such as Hydric Policies and the Valley of Mexico, the risks to cover the supply of Mexico at a home and industrial level, the new challenges of the water in the Valley of Mexico, technological innovations, water culture in Mexico, edited by the Porrua House, the economy of water, the lack of water, and the industrial use of water. She will present a paper that was jointly written with Dr. Jorge Morales from the UAM that is entitled Integration of an Economic Watershed and Hydric Network in the Valley of Mexico.
I will be referring to a project that in some way gathers the concerns we are dealing with here today, referring to the integration of economic accounts within a framework that includes water basins. This project is the result of the integration of researchers from different disciplines trying to give an answer to a problem, and in some way between economists and hydrologists we saw the need within the same project to give answers both to the problems of economic type and thinking also in political and social terms, but mostly thinking on economic terms. How can we integrate this economic problem with a water problem? And this is what our research is about. We will be referring to the case of to the specific case of the basin of the Valley of Mexico. Here I'm showing the basin. It's in color. We see 4 states of the Republic participating within the basin of the Valley of Mexico: the whole of the Federal District, part of the State of Mexico, Tlaxcala, and Hidalgo. From the viewpoint of the geographic demarcation, this is the map of the basin, and we don't see an exact coincidence between the administrative aspect in the previous map with geographic demarcation. There's a difference of 40 square kilometers, but in some way the base information that we have in order to carry out the analysis basically answers the statistics of the INEGI and annex statistics we have in regard to municipalities. So basically the information, as I was saying, is of an administrative nature, having as a basis the geographic aspect. What you see in green is the human settlements along the basin. Here we have the most populated area of the Federal District and the second most populated in the world, which are right now, and according to the census of INEGI, it represents 120 million inhabitants. The state of Mexico supplies a larger amount of population than it is the federal district. As you see here, 20.5 million is the present-day population, and the larger contribution comes from the state of Mexico. In 1990, the greatest population was the federal district, and now it has been overcome by the state of Mexico. And which are the goals we have in this integration of accounts? The main goal is what we have heard here today, which is to be able to provide water safety in the basin of the Valley of Mexico. To achieve our goals, we have to identify indicators, which is part of the contribution of this project. And the main goal of integrated basins is to identify which are the areas of economic or environmental stress that exist in the Valley of Mexico. What advantages can we have with integrated accounts? Integrated accounts, as we have repeated here, the UN, the World Bank, an integral vision, a systemic vision will allow us to measure variables of all types in one single plane and in one single place, to be able to identify how we can direct political answers to solve integral problems. These are the advantages of this type of work. The problem to achieve what we have heard here is how to ground methodology. In methodology, to achieve this integration, we need an enormous volume of information that has to be organized. How can we organize the information? In this case, and I will cover methodology quickly to go to the exercise itself. In this case, the basic element of the methodology is to take from the system of national accounts the information in order to provide an economic map of the basin of the Valley of Mexico. And in this economic map, locate the sector of water from the economic viewpoint in the first place, and in the second place from the hydric point of view. And we will do this in 4 steps. In the first place, I will define what the economic structure is and what we found. Then in second place, since Eugenio Reyes yesterday presented the methodological and preliminary results of the study of the hydric structure he is coordinating. And then hybrid accounts, which is the main result of this exercise from the statistical point of view. And lastly, the importance of information in order to define the policies that will allow us attain the goal of water safety. The economic structure of the basin in the Valley of Mexico. All the information that has been processed from economic census, national accounts, accounts of income, expenditure, administrative registries, all the set of information ends up in ordering the information, which is called a matrix of input product of the basin of the Valley of Mexico. And we have the economic structure of the basin of the Valley of Mexico. Here you can see the summary of the database of the structure of the basin. The original matrix includes 80 economic activities. That is to say, it is a very large matrix, and here I summarize the main results. For an economist, the reading of this table is easy. For those who are not economists, this requires an explanation, but I will refer to the most important elements included here. Look here, along the edges, we have the production of economic activities. For instance, agriculture in the basin in 2008, because this is an exercise where the statistics I have referred to can be put together. Here we can see the values of production, and in the lower part, the values of the production, the different sectors, or what we might call the private sector, is with a destination of the selling of the production, and in the lower part, the cost of the production. And what is a novelty here? These statistics are carried out very seldomly at the national level, because this has the matrix of input product at a national level. It is an input together with the other inputs I mentioned regarding the other statistics. And the result tells us that this sector, which is the gathering, treatment, and supply of water, is what we've been working on in detail with the water accounts, and especially through economic census. There are two censuses of water in Mexico. It's a census of 2003 and 2008. In this case, with the census of 2008, we can know how all the agencies and operators grouped here sell their production to each economic activity as far as this column. And here we have the persons that consume water and how much water they are provided in money terms, and a balance between imports, exports, in order to have the gross value of production. And on this side, we know how all the agencies and operators as a whole have a production process in order to add this value to water. And as you see, it's monetary units, and this is the economic framework that is opened in order to include the sector of water supply. And we have pending here something else commented by Eugenio yesterday, an additional column that will be referring to drainage or sewage. The information is not enough to include another column, but we will examine what all this is for. In a very quick overview, the structure of the basin tells us that services are the most important sector in the basin of the Valley of Mexico, because it brings together many services that are supplied both within and outside the basin. Another bit of information is GDP. The GDP, the value added, is the most important aspect of the economy, because that represents the wealth and growth of the country. In this case, the sector that provides the largest part is services, trade, and manufacturing. Here, the sector of water, from the viewpoint of production of wealth, is negligible. Something else that is important is technology. Obviously, we have this as an 80% of the activity. What I want to say here is that I want to refer here to the process of the gathering, treatment, and supply of water. Here we can see immediately that to produce 100 pesos in water value in the basin of the Valley of Mexico, we have a value added, which is payment in salaries. We see how much we require for the payment of electric power, which is an important aspect, and we can also see the different inputs. This also gives account of how companies position of how a cubic meter of water breaks down its value. This is the economic structure, and right now we will examine the water structure mentioned by Eugenio. Very quickly, we can see here how water that can be used can become superficial water, runoffs, and superficial water. And we can see the cycle of the hydrologic cycle of water. Here we see that we are in an endorheic basin where we had to carry out work in order to extract water from the drainage or the rainfall water in order not to be flooded. And in terms of hectometers, we have expressed how much water is extracted. 1930 hectometers, how much is recharged, what is the runoff of superficial waters, what is the hydrological cycle itself. And this information is basic to integrated to economic accounts. This is the interesting aspect. Now, the availability of the basin is 1404. The exploitation, which is the most severe problem we have, is 110 hectometers of overexploitation of the underground bodies of water. We have the sources of supply we have in the basin. The basin, we have 2,000 plus hectometers. We import 211 hectometers. In reuse, we have a very small amount. And the first use, which is superficial water and underground water, have a value of 2,107 hectometers. This comes from information comes from CONAGUA and from INEGI, the most important table in this economic matrix, and cross it with hydrological information. Origin and destination of water, underground water in the basin of the Valley of Mexico for public supply. It shows the amount that is destined, how much of this is destined to agriculture and manufacturing, giving us the total of underground water that is extracted, and the same to superficial water that is destined. Reuse and import. All imported water goes basically to public supply. And here we go to hybrid accounts. Mixing together both informations, we can obtain the following: the cost of supply of water in the basin of the Valley of Mexico, 4 pesos per square meter of water at a general level. The underground water is then 3 pesos, superficial water 2.29. In the basin of the Valley of Mexico, we would have, considering only the water that comes from the basin itself, 3 pesos. And imported water that we know is more expensive, it's practically 7 pesos. These data, the only ones we could obtain by us through this methodology that can be carried out for any region. Productivity of water. Another derivative of the account I was referring to. If I relate the hectometers used by the different sectors, but by the added value coming from the economic account, I see that the value added of produced is higher than commerce and services, and value added of agriculture is very low, or relatively low. Another possibility of hybrid account is to see how much it costs to supply household consumption. household consumption to supply this service. All homes pay 1,165 of the homes in the basin. The cost of provision is this is per cubic meter, 1.165 million pesos. The cost is 4,439. So there's a subsidy of 1.7 billion. No, the subsidy is over here. This shows how accounts and transfer of income can be provided through amounts of water in cubic meters and their monetary value. This obviously is essential for the decision making in economic policies. Now referring to the hybrid footprint or water footprint, these accounts relate to this. From the matrices, we derive how much we need directly in liters to produce 100 pesos of agricultural production in the electric power sector, in commerce, or the system of gathering and treatment of water. To produce 100 pesos, I require so many liters of water. All this information, basically here we wanted to present the management of information, the processing of the data, because the basis, it's a basis from which we produce models. We can follow different paths in the organization of this information. We can produce models that will allow us to carry out simulations for policies, both water and economic. Simple models like the model of multipliers or of the general, where we admit variations in the price of water or some input to see its impact in the whole basin. Or we can produce a map in detail, because the accounts I have provided are at an aggregate level referring to the whole basin, and we can analyze at a municipal level, but we have to determine the level for all the municipalities. This is a heavy statistic work, and we are doing it in order to find indexes of water vulnerability. And we can work towards virtual water, because these models, aside from estimating the direct volumes in the use of water, provide the indirect volumes in the uses of water. This is part of a methodology referred to this morning. It is slightly more complicated than the one mentioned this morning, because here we must have the whole set well structured to move certain sections and know what happens. When we do this outside of this context, sometimes we can obtain data that are not correct, and we have no way, no means to measure it. What we have added here, it compiles the behavior of the different parts, and we will always have control as to how these parts control the whole. In this sense, this is a result that has been part of this process, the learning process on behalf of those of us that are part of the water network of REWAM and RETAC, in looking for paths that in this case coincide with which the UN World Bank and the OECD are consolidating these to have a homogeneous basis. And well, when we want to have a region work at a regional level, we have to follow the methodology and be able to apply it to the space you are interested in. Thank you very much.